So we're looking at the Unit 2 review. First problem says, which of the following is a true statement? As we look through these, we first know that parallel lines never intersect. We haven't quite talked about them very much, but just coming in with prior knowledge, we know they don't intersect, they run parallel to each other. We know that perpendicular lines meet to form a right angle. So that's not that they never intersect, they actually do, they make a right angle. Intersecting lines are always perpendicular. That one's a problem because they don't have to be perpendicular, they can form different angles. So actually, the true statement is intersecting lines are never parallel. If they intersect, that means they have a point in common, which means they will never be parallel. For number 2, we're looking at the measure of angle CDE is 80. So this is 80 degrees. We have it's bisected by AB, which I see bisected, and that tells me that these two parts are equal. We need to find ADC. Well, back to the bisected part. If this whole thing's 80, then each of these are 40, which means when we look for ADC, which is out here, we have 40 plus that gives me 180. So it's 180 minus 140, or minus 40, gives us 140 degrees. Okay, on number 3 we have MPR, which is right here, is 20 degrees. And NP is perpendicular to PR, which is this angle here. We need to find LPN, which is this one. So if this is 20 and this is a right angle, then we know that NPM is 70, and then we need to find this angle over here. Well, this angle and this angle, the 70 degrees and LPN, add up to 180, so I could subtract 180 minus 70 gives me 110 degrees. Number 4, we have KA, this portion, is equal to BT. So we have, if those are equal, we have KB is congruent to AT. KB, AT are congruent. Okay. B is the midpoint of KA. A is the midpoint of BT. And A is the midpoint of KT. So we need to kind of work through and see what we know. Well, I know this is in both of them. The fact that BA is in both, and they're both equal, if I was to get rid of that, I would be left with these two parts being the same, which is KB is congruent to AT, because this portion plus the common portion is equal to the common portion plus this portion. They add together with the parts. This is also kind of a segment addition type problem. Number 5, we need to find the intersection of plane R and plane P. Two planes intersect to form a line. So we know that right off the bat. So this is out, it's not going to be point K. So it needs to be a line. We have TC there. So we even know those two are out, so we're left with answer C or D. The big difference is this is a segment, this is a line. Two planes, well, first of all, they're going to be infinite, so their intersection is also an infinite, so that's going to be TC. Even though, or line TC, even though D is the right letters, the fact it's a segment, and even though they show it, we have to realize it does go on infinitely. It is going to be the line. Number 6 is we need to find a counterexample to our statement. All real numbers have a reciprocal. If we remember, a reciprocal is when we can take the number and we put it underneath 1 as a fraction. So this would be 1/5. This would be 1 over 1, 1 over -7, and 1 over 0. So I can do that to all of them, but I need to see which one does and does not work. The one that doesn't work is B. And that's because 1 over 0 is an undefined number. We can't have that. The rest of them do work, so B would be our counterexample. Number 7, which of the following is the name for reasoning that uses facts, definitions, accepted properties, and theorems? The two we've looked at this chapter are B and C. The correct answer is C, deductive reasoning, because inductive looks at diagrams, specific examples, patterns based on observations. The other two, I haven't really talked about. Okay, on number 8, identify the hypothesis in the following statement. If we go back to conditional statements, if A, then B. The first portion is the hypothesis. The second portion is the conclusion. So our hypothesis here is the sum of two angles is 90. So B would be our hypothesis, and if it asked for the conclusion, C would be the conclusion. The other ones are not related to it, so we're not even going to answer those. So B is the answer B is the hypothesis if the sum of two angles is 90 degrees. Number 9 asks us for which two angles are supplementary and adjacent. Supplementary and adjacent are a linear pair. So if it's not one of them, it's out. First of all, it says two angles. This has three angles. That's out. Answer B. Well, they are supplementary. They add to 180. They're not adjacent. D. They add to 180, but they're not adjacent because they don't share a side and share a vertex. They both are on that line, but this vertex for both of them, these vertices are different. That's out. It leaves us with answer C. They're supplementary, they add to 180, as well as the fact they are adjacent because they share a vertex, they share a side. Number 10, we have angles AOB, which is here, and BOC. So which can they best be classified as? So we can immediately go through and eliminate things. This one means they add to 180, or they form a straight line. With that fact, they're both out. D is also because they should each be 90 degrees and 90 degrees. I have no markings, no measurements. That's out. B and C narrows it down because it can't be both of them. It's going to have to be one of them. Like I mentioned earlier, on the last problem, when they're adjacent, they share a side and share a vertex. They share the side, OB. They share the vertex, O. So that makes them adjacent. If they were vertical, just to give you a reference, it would be two angles on opposite sides of the vertex. Not the case here, so C is our best answer. 11 says linear angles are always what? And even if we go back up here to our linear pair, they have to be supplementary and adjacent. The fact that supplementary is listed right there, so we're going to go with that. One of them could be obtuse, it means the other one's going to be acute. One of them could be right, means the other one's going to be right. They're not going to be complementary. They're not going to add to 90 because they have to add to 180, but C is our best answer. Number 12, linear angles are never. Okay, well they have to be adjacent, so that one we know. They have to be supplementary, that one we know. They could be congruent, and they'd be congruent if they were both 90 degrees. So that one's possible in one case, so it's not never. It leaves us with A, vertical. They will not be vertical, and the main fact they will not be vertical is because they are going to be adjacent, and two angles cannot be both vertical and adjacent, because to be vertical angles, we first say that they're non-adjacent angles. 13, if two angles are complementary, then the sum of their degree measures. So this is one that's asking us what it means to be complementary angles. We go back to our definition. It means that two angles add up to 90 degrees. C would be our answer. Now, on the next 8 problems, we're just naming properties. So, we look, if we're given this equation, then we're here. So what changed? I had a -7 here. This was 29. Now it's 36. This was addition property. I added to both sides, and I added 7 to both sides, if we make a little note there. I have 3 times the quantity x plus y equals 3x plus 3y. We may remember this from our algebra days. I've used distributive property, and I've distributed the 3 to both terms inside the parentheses. 16. If measure of A, angle A, equals the measure of angle B, and the measure of angle B equals the measure of angle C, then A equals C. Notice in both of these, they both have B. Both A and C are equal to B, so they're equal to each other, and that's transitive property of equality. 17, I have AC is equal to AC. This is the property where something is equal to itself. This is reflexive property of equality. If angle A is a right angle, then the measure of angle A is 90 degrees. Well, if I asked you what is a right angle, you'd say it's an angle that's 90 degrees. That is the definition of a right angle. 19, if M is the midpoint of AB, then AM equals MB. If I trace that out, M is the midpoint, I have A, I have B. I know that those are the same, or their lengths are equal. This is a definition of a midpoint. 20, if the measure of angle X plus the measure of angle Y equals 90, then they are complementary. This is also a definition of complementary angles. Last one, 21, if I'm given that x plus y equals 14 and x equals 5, then I can say 5 plus y equals 14. I've replaced the x with the 5. When we replace, it's like substitution. So that's substitution property of equality. And we go to 22. We have the measure of angle 3 is 37. We need to find BDC. Well, if this is 37, I have a right angle here for BDC, or I should say ADC. So 37 and this angle, BDC, are complementary. So BDC is 90 minus 37, which is 53 degrees. Then we go to 23. BEC, let's scribble those out, is 88. We need to find CED, which is right here, and AED, which is right there. Well, I know these two are vertical, so I know AED is automatically 88 degrees. CED is next to it, it's adjacent to it, that's a linear pair, so it's supplementary, so that's going to be 180 minus 88, which is 92 degrees. Okay, next one. E is the midpoint of AC. Okay, so I know these two are the same. I know that AC is 28. I need to find AE. Well, 28 is the entire length. I want half of that, so AE, I guess it'd be on this side, is going to be 14 units. 25, I need to find the value of x and the measure of the angle. We look at this problem, we should immediately see that we have a right angle. So these two angles are complementary. 10x minus 8 plus 6x plus 2 equals 90. 16x minus 6 equals 90. 16x equals 96. That means x equals 6. Then I need to find ABC, which is this top portion. I can plug in the 6, I get 60 minus 8, or 52 degrees for ABC. So x equals 6, and the measure of ABC is 52. For 26, I need to find AED and AEB. Now I first look at this and I see, well, those x values are vertical to each other, so I can set those equal. Get 4x plus 12 equals 6x minus 14. That becomes 4x plus 26 equals 6x. 26 equals 2x, and x equals 13. Then to find the measure of angle AED, I'm plugging in 13 for x. 4 times 13 is 52, plus 12 gives me 64. Run out of space, so we'll just go up here to find the measure of angle AEB. Now we don't have a value for it, but we know this is 64, and this is the supplement, so it's adjacent to it, and we could do 180 minus 64. that is 116 degrees. And in fact, this would also be 116, and this would be 64 as well. All right, 27, you find the values of x and y. First we have to look, are they vertical angles for the x's and y's, or are they linear pairs and next to each other? If we look, these two are next to each other. That means they are supplementary. 3x plus 28 plus 7x plus 12 equals 180. I get 10x plus 40 equals 180. 10x equals 140, so x is 14. We're going to solve y the same way. 4y minus 2 plus 4y plus 38 equals 180. 8y plus 36 equals 180. That's 8y equals 144. Then y is 16. For 28, the complement of an angle is 3 more than twice the measure of the angle itself. So, let's do that one over here. I have complementary angles. So I know 90 degrees. I'm going to call one of them x. So the other one is 3 more than twice its measure. So it's 3 more than twice x. 2x plus 3. So there's my values, and I can say x plus 2x plus 3 equals 90. That means 3x plus 3 equals 90. 3x equals 87, so x is 29. We go back up, I have 29 degrees, and then 2 times 29 is 58, plus 3 is 61. There are my 2 angles. For 29, we need to write the statements as biconditionals. When we say biconditionals, we're talking about the if and only if. So I could say points are collinear if and only if, and you could always write out if and only if themselves, or just use the abbreviated version. They all lie in one line. 30, if points lie in one plane, then they are coplanar. I'm going to say points lie in one plane if and only if they are coplanar. Now, in order to write a biconditional statement, we have that the original statement and the converse must be true, but then at that point we can take those 2 true statements, combine them into one, which is our biconditional statement. 31 is a proof, but it's an algebraic proof, so we're going to use those algebraic reasons as we solve. So we look at our first line, it is given to us, so we make sure we write that as a reason. It is given. Anytime you do a proof, you're going to be given information. Always list that first. That's the automatic one. So I look at what I've done from line 1 to line 2. I had 6x minus 4, and now I have 6x, or 6 times x minus 4, and now I have 6x minus 24. That was distributive property. I've gone from 6x minus 24 equals x plus 16. There's no x now on the right side, but now 6x is 5x. It looks as if I've subtracted x from both sides. That is subtraction property, and if you want to write minus x there, maybe it gives you a little note to what you did. The next line, I have 5x equals 40. Well, the 24 is gone, and the 16 is now 40. I've added to both sides, so that is addition property. Added 24 to both sides. And I've gone from 5x equals 40 to x equals 8. That is division property, in which I've divided both sides by 5. On 32, we're doing a proof with segments. So we'll start with MO equals LD. Now that's our given. So we want to get to ML equals OD, which was this overlap here. And we found I had a problem earlier that referenced the same type of idea. I think it was the third problem. Number 4, it's the same idea. But let's work through what we have here. So we have two approaches. We can kind of work through the proof ourselves, or we can look at the statements and try to match up what we have. What's real nice is we have OL equals OL. If something is equal to itself, we call that reflexive property. That explains why OL is equal to itself. And then if we bring up reflexive property, we typically next either add or subtract that value from both sides. So I've gone from MO equals LD to having OL in both parts. So I've added, or done addition property, and that's adding OL to both sides. So now I'm here, and I'm really close to this final answer, because if I look, MO plus OL is ML, which is what I want. LD plus OL is what I want in OD. So these are the same things, but these are the parts, this is the whole thing, these are the parts, this is the whole thing. So we need to find a way to change it. Instead of talking about the parts, we want to talk about the whole thing, and that's where we get that last step, or this middle step, I should say. In this middle step, we're saying that the parts equal the whole, the parts equal the whole. That is segment addition postulate. And there's a couple proofs at the end of the video for section 2.7 that follow the same idea. So if you're not quite seeing this type of proof, there's two at the end that follow a very similar process that you can see how they're connected. But once we have this, now we can replace the parts with the whole, the parts with the whole. I said replace. That's a key word that maybe suggests that we're going to do substitution. Gets us to our final answer that ML is equal to OD. Okay, last set, we first start off with DOF is 90 degrees, so I'm going to mark that as 90. BOA is 40, and GOF is 60. Now when I get a problem like this, I like to kind of go through and start marking some other things that I know without looking at what I need, and maybe it'll help me along the way. So for example, I have a 90 degree angle here. Well, that means I'm also going to have a 90 degree angle over here because they're vertical angles. Which, if this is 40, then this is 50 because they add to 90, and you can go the verticals for the 40 and the 50 across here. Then I can go a little bit further. This AOE is a straight angle. Really, it's kind of a linear pair or a straight angle. I know this adds up to 180. I shouldn't say linear pair because then we're only talking about two angles. But here, I can line all these up. I have 50, 60, 40. That adds up to 150. What's left is 30 degrees that goes right there. We go in, look at the top half. Well, I have vertical angle again. I have BOC, GOF are vertical, so this is also 60, and in fact this is also 30, and we can go and fill in all of our values. So just by looking at the diagram and working through it, we found all the parts. Now it's going to be even easier to go through this list. So look for those vertical angles, look for those angles adding up to 180, and really I could go around in any direction, and I get that the angles add up to 180, but now we can find, maybe solve a little bit easier. So BOD, that's from B to D. That's going to be 60 and 30, 90 degrees. FOE, I'm going on the outside from F to E. If I look at that angle, it's 40 degrees. GOE, so GOE, that's from G to E. That's 60 and 40 is 100. BOC, B to C is 60. COD is 30 degrees. DOE, that's D to E, is 50 degrees. AOD, go from A to D. I'm going to add three parts together. That's 40 plus 60 plus 30 gives me 130. And last, BOG, that's these three parts. That's 40 plus 50 plus 30 is 120 degrees.